All right, so we're going to keep talking about quadratic functions. So I have one here. We have y equals x squared plus 4x plus 3. And we want to, it says write that function in as many different forms as we possibly can. So one form we know, like this one is in what we call standard form, right? We know how to put it into vertex form, right? That's what we just did a day or two ago here, but let's just review that really quick. So if I want to put it in vertex form, I'm going to take it and group the x squared plus 4x together. We need to complete the square there, so take half the middle number, half of 4, and square it. So 4 divided by 2 is 2, 2 squared is 4. And then on the outside, I need to subtract 4. I factor that. It factors to be x plus 2 and x plus 2, or x plus 2 squared. And 3 minus 4 is a minus 1. Okay, so we got standard form. We just did, now we have vertex form. This is vertex form. Okay, there's one more form we haven't done, and that is what's called, sometimes it's called, get this up here, intercept form. A lot of times I just call it factored form. And that's where, and we'll talk about why it's called intercept form in just a minute, but I'm going to take that x squared plus 4x plus 3 and factor it, just like we factored quadratics in the past. So I'm doing my two sets of parentheses, x and x. And we want the factors of 3 to add up to be 4, so that's just 1 and 3. So these are the three forms that you can put a quadratic function in. And each one gives us different information. So what we're focused on today is we've done a lot with standard form. We've done a lot with vertex form. What we're going to focus on mostly is this intercept or factored form, okay, and what information I can get off of there. So really quick, down here I have those three forms written, plus I also graphed it. So these are all the same function, right? This is the standard form. This is the vertex form. And this is that intercept or factored form. Well, there's some connections between the graph and those three forms. So what I want you to do is pause the video for a second and see if you can figure out what they are. All right, so hopefully what we saw is one thing is if I look right here, the y-intercept is at 3, and when it's in standard form, there's a plus 3 right there. It turns out that when your graph is in standard form, you can look at that constant at the end, right? I'll highlight it instead of that constant at the end is going to give you the y-intercept. Kind of think about y for a second. When you're looking for a y-intercept, if I'm on the y-axis, that means x has to be equal to 0. So if I plug 0 in, I get y equals 0 squared plus 4 times 0 plus 3. Well, what's going to happen always if it's in standard form is that term's going to come out to be 0. That term's going to come out to be 0. And so the y-intercept, when I put 0 in for x to find the y-intercept, it always equals that constant, that last number on the end. So that's a connection we make with that. Vertex form, that one should be obvious. We've done that a lot, right? If it's in vertex form, it tells me where the vertex is, right? The vertex is at -2, -1. Okay, factored form, this is the one we're really focused on today. When it's in factored form, hopefully you noticed, it crosses the x-axis at -1 and -3. And if you look at the function up here, it's x plus 3 and x plus 1. Okay, and the x-intercepts are at -1 and -3, and that's not a coincidence. So if you think about this for a second, if you're looking for an x-intercept, I'm looking along that x-axis trying to find an x-intercept, no matter where I go, one thing has to be true, and that's that y is equal to 0. So what I'm really doing to find the x-intercepts is I'm putting 0 in for y. Well, when I get to right here, what that means, right, we know how to solve this equation. We've done this. This is in our last test, our last chapter, is I just set each of those factors equal to 0. So x plus 3 equals 0, and x plus 1 equals 0. So I get the answer of x equals -3, right? There's right there, and x equals -1 right there. Okay, so just to summarize, put this in your notes. These are what we can get from those three forms of a quadratic. Whoops, sorry about that. If it's in vertex form, then it tells us the vertex. The vertex is at HK. We've done a lot of that. If it's in standard form, then the C is the y-intercept. So the y-intercept is at C. Let's put it as a point. X is 0, y is C. So that gives us this, right? That right there gives me the y-intercept. Also, just add this in your notes there. Yesterday, we talked about how we can find the vertex also by using A and B. So in a roundabout way, you can get the vertex from standard form. Okay, this is our new form now, right? This is what we're focused on today, and that's this intercept form or this factored form. Well, what we just said is if you look at those factors, by the way, this A, let me just real quick before I go on. A, right, here, it's the same in all of them. Just remember what that does. It doesn't matter if it's, which form it's in, that number is the same. It controls whether it's opening up or down and the stretch or compression. But what factored form gives us besides that is it gives us, if I take those two factors and find out what makes them equal to 0, so I go x minus p equals 0 and x minus q equals 0, I end up with p 0 and q 0 are my two x-intercepts. So what form do we want it in? Well, that really depends on what we're trying to accomplish. If I want the vertex, then the easiest form to have it in, right, is the vertex form, right? That gives you the vertex right there. If it's in standard form, okay, then, hey, that's great for finding the y-intercept. So if I want the y-intercept, I want it in standard form. If I want the x-intercepts, right, I know what p and q are, where it crosses the x-axis, then I want it in this intercept factored form. So we want to be able to move between these different forms, right? If it's in vertex form, we want to be able to put it in standard form or factored form. Or factored form, go to standard form or vertex form. We're going to practice that later on. But for today, we're just going to focus mainly on this intercept form and really get to know it really well. So this is our learning goal, right? I can find the x-intercepts of a quadratic function, okay, and use it to graph the function. We're going to skip past this for just a second, but we'll come back to it. All right, so let's just do this example. So it says graph f of x equals negative x plus 1 times x minus 5. So I always start by identifying what form our quadratic is in. This one is in factored or intercept form. Hey, what that means is it's easy to find the x-intercepts. So I could actually just multiply this out and put it into standard form or vertex form, but there's actually an easier way. So if I know what the factors are, I know my factors are x plus 1 and x minus 5, I just want to find out what makes them equal to 0. So this would be x equals negative 1, and this would be x equals positive 5. Okay, so those are my x-intercepts. So I know it crosses at negative 1, 0, and it crosses at 5, 0. Let's put those on the graph, and then we'll talk about how we could draw the rest of the parabola from that. So I got a point at negative 1, 0. I got a point at 5, 0. So what we can do is when you think about this, parabolas are symmetric. So if there's a point, if I have those 2 points, I know that halfway in between those 2 points, it has to be where the axis of symmetry is. So if I count over 1, 2, 3, 4, 5, it's 6 units between those 2 points. So if I count 3 either way, this point right there is the middle. That's halfway between those 2 points. And so I'm going to draw my axis of symmetry. I know that's where that's got to be. And we can write that down. I know my axis is, so these are my x-intercepts up here. I know that the axis of symmetry is at x equals 2. And again, I found that just by finding the point halfway in between. Well, what that also tells me is, it tells me my vertex has to be on that axis of symmetry. So I don't know what the y-coordinate is, but I know somewhere up and down this line, right? Somewhere up and down that line right there, you got to have the vertex, which means my x-coordinate has to be 2. So hopefully that makes sense how I got that. I found the point halfway between the negative 1 and 5, which was at 2. That means that's where my axis of symmetry has to be, and my vertex has to fall on that axis of symmetry. That means that it has to be the x-coordinate of my vertex. All right, now all I'm really missing, if I could find the y-coordinate of the vertex, we could sketch this. Well, we know how to do this. We talked about this in the last lesson. If I know an x and I want to find a y, I can just take the x, right? Take my x, and I can just plug it in for x in my equation. So I get f of 2 equals negative, just plug in 2 in, 2 plus 1 times 2 minus 5. If I can figure out that's equal to, that tells me my y-coordinate. So it'd be a negative 2 plus 1 is 3, times by 2 minus 5 is negative 3. I times those together, positive 9. So my vertex is at 2, 9. So I'm going to go up here. I should have made my graph larger, but 1, 2, 3, 4, 5, 6, 7, 8, 9. My vertex has to be there on 2, 9. And I don't care if you find other points. You could, but this is enough for me. If you know where the vertex is and the x-intercepts are, then I think we're happy. So there's my parabola right there. Now it does say to find the domain and range. We've done that a lot. Let's just review that. Domain is always all real numbers on these. That graph goes forever left and right. Sorry, that's supposed to be the symbol for all real numbers. Are there? The range, right? It starts at 9, and the graph is less than, it's below 9. So I'm going to say y is less than or equal to 9. Or you could always do that interval notation, negative infinity to 9. Okay, that would be okay also, depending on how you want to write that. So if that kind of makes sense, we can actually use the x-intercepts to figure out where the vertex is. All we do, put my x-intercepts on the graph. I'll do it a different color here, right? I got an x-intercept there, and just find the point halfway in between. You could do that by looking at the graph. Now, just think about this for a second. There's another way to find that, is you can actually, if I just take my two x-intercepts, negative 1 and 5, and I want to find the point halfway in between, we can actually just add those together and divide by 2. What that really does is give us the average of the x's, but that will be the point halfway in between. So negative 1 plus 5 is 4. 4 divided by 2 is 2, right? So if you ever get confused or it's hard to tell on the graph where the middle is, you can use that little trick where you add them together and divide by 2. In fact, let's add that to our notes. Go back up to where we put the intercept form, and let's add this on there. If you want to find the vertex, okay, and it's an intercept form, we can take P and Q, all right, our two x-intercepts, and all I do is add them together and divide by 2. And that will tell me where the x-coordinate of the vertex is. And then you have to plug in the x back into the equation to find the y-coordinate. Okay. I'm going to skip over that one. Let's try a couple of these. So let's do number 2 together. Then I'll have you try one, and then I'll show you one that isn't already in factored form. We'll try one of those. So notice the directions. It says graph the quadratic function, label the vertex, axis symmetry, and the x-intercepts. Describe the domain and range of the function. If it's asking you to find the x-intercepts, it's awesome if it's in factored form because it's quick and easy. Right, my two factors are x minus 4 and x plus 1. So my x-intercepts, make sure you change the sign. They're at a positive 4 and a negative 1. So those are my x-intercepts. All right, next, let's find the vertex. So you can do that one of two ways. We can draw the graph, put those points on there. I have 4 and negative 1. So if you count the distance between there, it's over 5. That means I have to come 2.5 from either side. Half of 5 is 2.5, right? So I'm going to go over 1, 2, 2.5, or 1, 2. You can come from either side. That's going to put me right there in the middle. So that's where my axis of symmetry is. And that was when x was, so my vertex was when x was 1.5. I think I might have said 2.5. I don't know what I said. We go over 2.5 from either side, but that puts me on the x-axis at 1.5. Now that's only the x-coordinate. We still need to find the y-coordinate. But before we do, just a quick note. If you want to use that formula to find the 1.5, you can do that. I would just go 4 plus negative 1 divided by 2. So 4 plus negative 1 is 3. And 3 divided by 2 is 1.5. So if you want to add them together and divide by 2 rather than counting on the graph, you can do that. That works out fine. Okay, let's see what we got left. We got the axis symmetry too. It's x equals 1.5. So we're almost there. I just need to find the vertex and graph it. And I think we'll skip domain and range. We've done a lot of that lately. I think we're good on there. Okay, this is a little bit tricky. So I've got to take the 1.5. That's my x. I've got to plug it back into here to find out what it comes out to. So I'm going to go g of 1.5 equals negative 2 times 1.5 minus 4 times 1.5 plus 1. And then where it's a decimal like that, I would just grab a calculator. That's what I'm doing. And I just plug that whole thing in. So negative 2 times 1.5 minus 4 times by 1.5 plus 1. And I get 12.5. Okay, so now we got the vertex. I'm going to, I don't know. I'm going to say that's 5, 10, 12.5 would be somewhere up here. I'm just going to approximate there. Draw my parabola. Hey, and notice that negative 2, right? My graph's opening down because a was negative 2. So that still fits. Okay, so if it's in factored form, it's great for finding x-intercepts, but you can use it too. If you know the x-intercepts, you can use that to find the vertex. Okay, I want you guys to try this one. Try it real quick and then come back and see if you've got it. So do this one on your own, number 1. Pause the video, and when you come back, I'll go run through it with you. So if it's x plus 2, that means one of my x-intercepts is negative 2, 0. And if it's x minus 3, one of my x-intercepts is 3, 0. Okay, let's put those on a graph. So at negative 2, 0, it crosses the x-axis, and at 3, 0, the difference between those is 5 again. So if I go over 2.5, I think that's going to put me at a half. It puts me right in between there if I go 2.5 either way. Or the other way to do it right is to go negative 2 plus 3 divided by 2. So that'd be 1 over 2 or a half. So I know my vertex. These are my x-intercepts. I'm going to come over here, I guess. I'll come up here. I know my vertex is at 1/2 or 0.5, and I got to find the y. All right, to find the y, you just plug it back in the equation. So f of 1/2 equals 1/2 plus 2 times 1/2 minus 3. And again, that's like 2.5 times, a negative 1.5. But you can just plug that whole thing in a calculator if you want to. That's what I'm going to do. 0.5 plus 2 times by 0.5 minus 3. Okay, and we end up with negative 6.25. That's kind of weird to have it's kind of weird to have a decimal and a fraction together, but that's okay. Okay, so if I go to my graph, I'm going to go down 1, 2, 3, 4, 5, 6.25. Let's just draw that axis of symmetry all the way down. So somewhere right down in there is where the vertex is. Okay, draw the parabola that crosses through there. Okay, and I got my graph. All right, when it gets a little bit trickier is like this last example. When, I'm going to look, this one down here is the one we're going to do if you want to write it down. So y equals negative 2x squared plus 12x minus 16. This one is not in factored form. It's in standard form, and we could use standard form to find the vertex. But because the problem's asking me for x-intercepts, I'm just going to factor it and then once I have the x-intercepts, I can find the vertex also. All right, so we've got to remember our factoring a little bit. I can take a negative 2 out of all three of those. So if I factor out a negative 2, it leaves me with x squared minus 6x plus 8. And then I'm going to factor that. X and x, and we got the factors of 8 to add it to be negative 6. That'd be minus 2 and minus 4. So now I've got it in factored form. So a is equal to negative 2, and then these are my two factors, x minus 2 and x minus 4. That means my x-intercepts are at 2, 0 and at 4, 0. Don't forget to change that sign. Let's figure out where the vertex is. This one's pretty easy. I'm just saying, if I got a point, I'll put it over here. If I got a point at 2, 0 and at 4, 0, well, halfway in between those has to be 3, right? Oops, sorry. A little crooked there. So I know that the x-coordinate of my vertex is at 3 something. Somewhere along that oh my gosh. Sorry, axis of symmetry. My mind went blank there for a second. Okay, well, let's find out what the y-coordinate of the vertex is. So I'm going to plug it back. You can either plug it into the original function or you can plug it in the factored form. It doesn't matter. I'm going to plug it in the factored form. I have -2 times, plug the 3 in there. 3 minus 2 is 1 times 1 minus 4 is -3. Okay, I times those all together and I get 6. So when I plug 3 in, I got 6 back out. Okay, so I come over to my graph. And at 3, 6, there's my vertex. And there's my parabola open in that direction. Okay, so if you're asked to find x-intercepts, you want it in factored form. If it's already in factored form, great. You can look at it and tell what the x-intercepts are. If it's not, you're going to have to factor it first. Okay, the other thing I wanted to show you was zeros. So if I ask you to find the zeros of a function, I want you to write down this definition. The zeros of a function, okay, they are simply what you would plug into the function to make it equal to 0. So it's what you plug in for x in a function to make it equal 0. Okay, so it's what numbers you could plug into a function to make it equal to 0. I don't care if you write this next part down. Just read this with me. It says factors and zeros. It says for any factor x minus n, so if you have a factor x minus n, that means that n is a 0 of the function. And I'll show you kind of an example on what that means. It sounds, that definition makes it sound complicated, but it's really not. So if I go back, if I come down to here, here's an example. It says find the zeros of this function, f of x equals x minus 1 times x plus 2. So remember what we're asking. We're saying, what would I plug in for x to make this equal to 0? So really we're trying to do this. What would I put in for x to make it equal to 0? Well, this is what we were just talking about. Like, if I want this to equal 0, either that has to equal 0 or that has to equal 0. So it either has to be x equals 1 or it has to be x equals -2. Well, those are also the x-intercepts. So we want to make a connection here. The zeros of a function are also going to be the x-intercepts of a function. Now, the difference is when you write zeros, you're just asking, what would I plug in for x to make it equal to 0? When you're doing x-intercepts, they're actually a point on the graph. So I would say the x-intercept is at 1, 0 and at -2, 0. So the x-intercepts are points. The zeros are just the x values. They're just what you plug in. But they're connected. They're the same thing, right? 1 and -2, 1 and -2. So when they say find the zeros, all we're really doing, we're going to do the same process, find what the x-intercepts are. Okay, and those are going to be your zeros. Let me show you another example down here. Find the zeros of each function. Let's do b right here. So if I want to find the zeros or the x-intercepts, I want it in factored form, in intercept form. So let's put it that way. I'm going to take this and factor it. I'm going to take a -2 out. It's kind of like that last problem we just did. Make sure you change all the signs. So x squared plus 5x plus 6. I'm going to factor that part. So -2 times x plus 2 and x plus 3. All right, there's a. A is -2. But these factors are what give me the x-intercepts or the zeros. So all I'm doing is what makes x plus 2 equal to 0? That'd be -2. What makes x plus 3 equal to 0? That would be -3. Hey, the only difference is if I ask you to find the x-intercepts, the only thing that would be different is you would say, hey, the x-intercepts are the point -2, 0, and -3, 0. Like those would be the x-intercepts, those are the zeros. So the zeros are just the x value that you plug in to get 0 back out. All right, the only other thing we need to go over is if you work backwards here. And what I mean by that is look at these two problems. It says write a quadratic function in standard form who satisfies the given conditions. So A, these are two different examples. Let's start with A. It says the vertex is at -3, 4. Well, if it gives me the vertex and I want to write a quadratic function, like we have three forms that I can use. I've got vertex form, I've got standard form, and I've got factored form. Well, if it gives me the vertex and I want to figure out what the equation is, I'm going to use vertex form because h and k is just the vertex. So all I have to do is this: y equals a times x minus a -3 would be x plus 3 plus 4. And now really all I'm missing is what a is equal to. Well, in this case, there are a lot of parabolas that have a vertex at -3, 4. It could be opening up, it could be opening down. It could be doing a lot of different things. And because it doesn't give me any more information, I'm just going to put whatever I want in for a. So this would be an example of an answer. It could be y equals x plus 3 squared plus 4. Or I could put y equals -1/2 times x plus 3 squared plus 4. Those both have a vertex in the same spot. Or I could put y equals 10 times x plus 3 squared plus 4. I can really put anything I want in for a because it doesn't give me any detail there. It doesn't give me any other information that would allow me to find a specific quadratic function. So there's a lot of answers for that part A. Okay, let's compare it to B. So if you read B, B does not give us the vertex. Okay, it gives me these points. It gives me the points -9, 0, -2, 0, and -420. Well, -9, 0 is an x-intercept. And -2, 0 is also an x-intercept. And I know that because the y-coordinates equal to 0, right? If you put those 2 points on a graph, they are on the x-axis. So I'm going to use this factored form over here. I'm going to go y equals a times, and just remember that p and q are just the x-intercepts. So I've got x minus -9. That's going to change to a plus 9. And I've got x minus the other one, x minus -2. Again, that's going to change to a plus. So I end up with this equation, y equals a times x plus 9 times x plus 2. Now, if it only gave me these two right here, that's really as far as I could go. I would just have to pick a number for a, and you could pick any number you wanted. But in this case, they give me more information. They give me another point over here. I got this point, -420. If you have another point, we can go back and figure out what a is equal to. That's what we're going to do right now. So what I'm going to do is I'm going to take -4 for x and 20 for y, and I'm going to plug those in for x and y and solve. So I'm going to put 20 for y. 20 equals a times -4 plus 9 times -4 plus 2. And I just got to work this out and find out what it comes out to. Okay, so now I've got 20 equals a times what? -4 plus 9 is 5, and -4 times plus 2 is -2. If I times those together, I end up with 20 equals a times -10. Then I want to get rid of the -10, so I'm just going to divide by -10, figure out what a is equal to. So a is equal to 20 divided by -10, which is -2. Okay, so I come back up. My equation, my final answer for this part B is going to be y equals -2 times x plus 9 times x plus 2. There's my answer right there. So on this assignment, on this practice, you're going to get two different types of problems. One is where they give you the vertex. If they give you the vertex, we're going to use the vertex form right there, right? If they give you the vertex. If they give you the x-intercepts, then we're going to use that intercept form or that factored form in order to find that. Standard form, we don't use very often when I'm finding a quadratic equation. And the reason why is, I guess if they gave me the y-intercept, you could plug that in there. But it's really difficult to find a and b. And so normally we're going to use either the vertex form or the factored form. And that's true on all those problems you have on today's assignment. Okay, I think that is everything. That's a lot fast. Make sure if you get stuck at all, come back, watch any of these examples from the videos. They should be pretty similar to what you have on your assignment. Thanks, guys.